Well, dear students, good morning. Here today, I am taking the topic series LR combination across AC source. Series LR combination across AC source. In this figure, combination of inductor and resistor, यानी कि solenoid and conductor are connected across a source. Now here we know, I'm right that. We know that in case of inductor, voltage leads the current. By voltage leads the current in phase by pi by 2. While in case of resistance, current and voltage are in same phase. So vectorly यानी कि phasor diagram, vector diagram, if this direction is I, the potential divider R is the same direction VR, and VR is this. Now if we connect, these are RMS voltage, not instantaneous. Instantaneously you can write here minus L di over dt plus IR, algebraic sum होगा equal to V0 sin omega t. V है इनका algebraic sum. But what we are doing here, these are RMS voltage. Here I write here VL and VR are the RMS values of voltage which have phase different 90 degrees, means their direction are at 90 degrees from each other. If we are in the east, then we are along the north, and therefore if we connect here voltmeter here, that will measure the RMS value of source as well as sum of RMS value, vector sum. So that sum will be given by law of parallelogram like this. So this is the vector sum of RMS voltage, which is equal to RMS voltage source, and therefore RMS voltage of source or magnitude of vector sum of voltage across inductor and conductor is given by V equal to under root VR square plus VL square. This is that voltage, vector sum, which the voltmeter will read. And this voltage here has phase difference with VR or I. And therefore, But now we know VR equal to IR or VN equal to IXL. Remember the name of XL? Inductive reactance. Therefore, V equal to under root I square R square plus I square XL square. You can take I outside, or you can write V equal to I bracket R square plus XL square. Here V upon I, dimensionally V upon I, equal to resistance. But here the two things are there, inductive reactance and resistance. So this V upon I here is equal to Z, is called impedance of circuit. Impede, there is word impede, which means to oppose. So this is impedance is the position of series LR circuit to the current. And it's a vector sum of resistance and inductive reactance Z. So Z equal to under root R square plus. This is very important question. You can define reactance and impedance. Define reactance and impedance. This question is very commonly asked in board exam, class 12. It is also important for competitive exam to solve many problems. So here, what is reactance? I told you inductive reactance, property of inductor which opposes the flow of alternating current. And XL equal to, I have told you 2 pi FL also, omega L. Omega L inductance unit Henry, and XL has unit of ohm, R has unit of ohm. Now, this voltage, which the voltmeter will read, leads the current in phase. The resultant RMS value of voltage, the resultant of RMS value, of voltage leads the current by an angle phi in figure, rocket diagram, and tan phi equal to here trigonometry. This is VL, so VL upon VR, but VL or tan phi, IXL upon IR, or tan phi equal to XL upon R. Numerical are asked generally on these topics very frequently in board exam and every exam. You have to remember, and here you have to remember that in case of inductor, voltage leads the current by pi by 2. In case of resistance, current voltage in same phase. So resultant voltage is this. In AC circuit, the current, the resistance, the reactance, the inductance, inductive reactance, all are vector quantities. While it is taught in class allowing that voltage potential difference is a scalar quantity, but that is true in case of dart current circuit. So it was something about series LR circuit. I may solve a question here because there is time. When 100 volt DC is applied across an inductor, 1 ampere current flows. 1 ampere current flows. But when 100 volt DC, 100 volt AC, 100 volt and 50 hertz AC source is applied across the same inductor, 0.5 ampere current flows. Find resistance and inductance. Inductance means L of the inductor. This is a simple question here. While discussing, I took pure inductor. Actually, what is inductor? I told you it is solenoid. A solenoid or any conductor in form of coil, maybe like the circular at one point, the spiral. So that is made up of copper wire has resistance. I took there just to understand the behavior. So when DC applied only 1 ampere current flows, when AC applied 0.5 ampere current flows. Why? Actually this inductor has inductance L and it will behave like inductor and resistance circuit 3. So when we apply DC, for DC inductive reactance 0. For DC inductive reactance 0, only resistance will act. So solution क्या लेंगे हम? In the solution, in case of DC, inductive reactance XL equal to 2 pi FL is 0. Why? Because frequency of DC is 0. I mean that does not change the frequency 0. So, resistance of conductor will oppose the current. Inductive reactance has nothing to do there. And so current is larger, that is so, and hence R is equal to VDC upon IDC is equal to 100 upon 1 ampere, 100 ohm. Resistance of the inductor 100 ohm. In AC the resistance and inductive reactance will oppose the current. And vector sum of resistance and inductive reactance is called impedance. So Z is equal to V upon I. V 100 upon 0.5. यानी कि it is Z equal to 200 ohm. Now you know R 100 ohm, you know Z 200 ohm, and you want to find L. So L we can find if we know XL, and we know that R square plus XL square is equal to Z square. So 100 ohm 10 to the power 4. So 100 comes to 10 to the power 2 square 10 to the power 4 plus XL square. Z 200 square 4 into 10 to the power 4. 200 square means 2 into 10 to the power 2 square. So it will be this. So from here, what is XL square? XL square will be 4 into 10 to the power 4 minus 10 to the power 4. लिख दो बच्चे नहीं परेशान हो जाना. How to subtract this? Take 10 to the power 4 common, so 4 minus 1 3. Dear student, please improve your arithmetic skills, and skills are improved only by practice. सिर्फ एक बार कर लेंगे ये होता है. Unless you apply it, it will not be in your control. So XL equal to under root 3 into 10 to the power 2, or XL is 2 pi FL root 3 1.732 into 10 to the power 200. 2 into 3.14 into 50 F50 L is equal to 1.732 10 to the power 200. 52 is 100. So L is equal to 1.732 upon. If we divide, we will get nearly 0.55 or 56 Henry. So this is a very good question just to understand the behavior of inductor and resistance when connected. So this is a good question. I will tell you one more question later on. Please revise the things regularly, only then you can learn. Thank you.